Okay, class, picking up where we left off at, we were rolling a 2 and we're trying to find the probability of that event occurring. So we know there are 6 different outcomes on one die. And then it's only 1, 2 on the die, so it'll be 1 out of 6. Now it says number 15, rolling a number less than 5. So let's think about all the numbers that are less than 5 on the die. It's 1, 2, 3, and also 4. Okay, so we have these numbers that's less than 5. It turns out to be 4 of them. So remember, the die still has 6 outcomes on it. So what we would do is we would have our 6 outcomes in our denominator, and then also these 4 here. So it'd be 4 divided by 6. So it'd be 4 possibilities out of a total of 6, and we could simplify that, and that would give us 2/3. Now we have rolling an odd number. We think of the odd numbers on a die. It'll be 1, 3, and 5. There are 3 of them. So we know there are 6 possible outcomes. And for the odd number is 3 out of the 6 possible outcomes. We divide both by 3 and we will get 1/2. Okay, now we go on to the next slide. Okay, now number 17 is a little lengthier than the other problems as far as their directions. It says here, if 3 coins are flipped, write the sample space. Remember that tails, heads is a different outcome than heads, tails, even though both result in 1 tail and 2 heads, which by the way sounds like a bunny rabbit from a horror story. Okay. Anyway, there they are with that humor again. All right, now, this is basically what it's saying. We're looking at combinations. We're not looking at that, okay, I got 2 heads and a tail, and we only counted once. If the tail comes first, and then we have 2 heads, but then the head comes first, and we have a tail heads, those are different outcomes. So we have to list every possible outcome that we could have with that coin. So we would do the set. So it's a set of, now one outcome would be 3 heads. Another outcome would be 2 heads and a tail. Another outcome would be head, tail, head. And then another outcome would be tail and then 2 heads. And then another outcome would be head and 2 tails. Another outcome would be tail, head, tail. Another outcome would be 2 tails and a head. And then the final outcome would be all tails. So that should give us a total of 1, 2, 3, 4, 5, 6, 7, 8 outcomes. There are no other outcomes for flipping 3 coins. So these are all of the outcomes. Now we're going to use this to actually do problems 18, 19, and 20. So let's get to that. Now again, this is on page 303. Okay, now it said for questions 18 through 20, 3 coins are flipped. Find the probability of each event. Now, first of all, we know all possible probability or all possible outcomes is 8 different possible outcomes that we have. Okay, now we ask ourselves, what if we had 2 tails? We'll go back here and we will look for each one of these that have 2 tails. Is actually, let's see, we have 1, 2, 3. We have 3 out of 8 that has 2 tails. So this will give us 3/8. Now we have this, number 19. It says at least 1 tail. So let's look again at what the definition of at least means. That means that it could be 1 tail or higher. So we have here, if we look here, all of these have at least 1 tail, except for all of the ones that are heads. So that would be 7 out of 8. Now it says at most 1 tail. So that means that the most that it can have is 1 tail. So we look here. At most, one tail will be 1, 2, 3. Okay, that's at most one tail. But at most means it could be that value or lower. So if it's at most one tail, that means that we could also pick one that does not have any tails at all. So it'd be 4. So it'd be 4 out of a possible 8. And we could simplify that, and that would give us 1/2. Now, we go to problem 21. Now, with problem 21, it says, explain why a probability can't be negative. Now, remember, we were told earlier that a probability can only be between 0 to 1. It cannot be less than 0, which would be negative, and it cannot be greater than 1. So it says, explain why a probability can't be negative. Well, this is what we could do. To explain why a probability can't be negative, an event cannot have a negative number of possible outcomes. Because think about it in more practical terms. Like, for instance, if we ask what is the possible outcome of rolling a 7 on a 6-sided die, we know that that outcome is 0. It would never go to negative. It would either be 0, it would be 0. So it can never go to negative. So think about any event that you could think of, and the probability of it happening, it cannot go lower than 0. So it would never be negative. Now, observation 2, probability is never greater than 1. Explain why probabilities are never greater than 1. Now, it'll be an event cannot happen more ways than the total possibilities. So, for instance, when we were doing the problem with the coin, we know that we only had 2 possibility heads and tails, and that's all that it would be. So you're either going to get a head or tail. You're not going to get anything else. So that's why it's 1. 1 is the most that it can have. Because I'm going to do a little example here. We know when you flip a coin, there's only 2 possible outcomes. So if you get both of the outcomes, it'll just be 2 out of 2, which is 1. You can never get higher than the total amount of outcomes. So just remember that. All right, now we move on to problem 23 and 24. Now let's look at 23. It says, explain why impossible events have probability 0 and certain events have probability 1. Okay, we already talked about that, but let's formalize this. Impossible events have, I can make that T in events look a little better. Possible events have 0 ways they can happen. And we know 0 ways just means no ways that it can happen. There are certain events must happen. So all possible outcomes are that event. Now that is to answer the question about having a probability of 1. Now the first one was the probability of 0, the first sentence. The second sentence was related to the probability of 1. Okay, now number 24. Explain why the probabilities of all outcomes have to add up to 1. Thinking of rolling a die might be helpful. Okay, so if you roll a die 6 times and you get all 6 numbers, you got all of the possible outcomes for that die because it's 1 through 6. So we could say that all outcomes would account for all possibilities so 100% chance or 1. Now, this is basically it from section 4.1, and thank you.